working actually at the Montreal University. He's one of the specialists in the blockchain technology, and I guess he will have a lot of things to present today. So, s'il vous plaît, accueillez notre présentateur, Abhinav, qui va donc nous faire la présentation sur le blockchain. Merci.
Good evening, everyone. So, thank you, William, for introducing me and getting me here. So, I'm a master's student at Montreal University. And so we specialize at cybersecurity and blockchain technologies. So I started, I did one course in blockchain with Professor Clark. He's a renowned professor at Concordia. He specializes in blockchain. And I'm also now working on a research project which relates blockchain, which I will be discussing as an application. So the topics will be like, what is blockchain? I will be discussing a brief about how blockchain works using examples of Bitcoin. Then I'll move over to some internals and its working, like what data structures are there, how internals work. Then I'll move towards the applications where I'll use the Ethereum technology, and then I'll present my project as an example to have more idea of how things work. Then I'll talk about more of like future upcomings where you can use blockchain with alternate and established technologies like cloud storage system, etc. And then there's a question answer round. If you have any questions, I'll be happy to answer. So all the material is prepared from my class notes and my own project, and the notes were prepared by Professor Clark. So I would like to thank him. So to start, I would just want to know, how do you perceive blockchain? According to you, what is blockchain technology, and how does it, what does decentralization mean? Can anyone say in one or two lines just to start the topic? Anyone?
About security?
It has a component of security, it was derived from the security components of cryptography, and digital signature hashing algorithms. So yeah, it has a component of security. Yes?
I think encrypted database?
You cannot say it as a database, but yeah, it has a storage and a ledger-based system. So not exactly a database, but on the following lines. So just to explain, blockchain will take a digital monetary unit, suppose any money value, and this is a bank. So if Alice wants to send Bob money, suppose $5, she needs to have a bank account and some money in it, or a credit card. And the bank holds her money and control of whether Alice can transfer $5 to Bob, or if she has $5 or not. So what she can do is she can spend without bank, but she needs the bank to authorize a transaction. Once you send the transaction, it's the centralized authority which needs to take control over it. But what happens in blockchain is you don't have a centralized authority. No one acts as a centralized authority. If you have 100 people in a network, then 100 of them are called the owners, and some special nodes are called the protectors or the miners who keep the ledger up to date. So here it's a ledger-based system where there is no control of a bank. If Alice wants to send Bob 10 bitcoins, or Karen wants to send Alice 5 bitcoins, she can send it directly, and the nodes in the network will take a call of whether Alice can send this money to Bob or not. So suppose Alice has 15 bitcoins right now, and Bob has 18. And Alice wants to send 5 bitcoins to Bob. So what will she do? The money from here will get deducted, and a ledger will be made. Alice is sending Bob 5 bitcoins. Her balance goes down, and Bob's balance increases. So you can see she is left with 10 and Bob is having 23. So this thing is like how Bitcoin works. If you want to do a transaction, this is how the things work. Like you can send money, receive money. But what happens at the back? Like if you see this ledger is just for a reference. This ledger actually doesn't exist anywhere. Like in case of balance, like you don't have, like if you open your bank application, you see, okay, the bank says you have this much money. But this money has to be bought up from the blockchain. So once you run a node of a blockchain, then all of the transactions are caught up, and then this balance comes up. And these are like when the earlier version of the blockchain and the Bitcoin came, there was no such thing of having a balance. You had to manually go and fetch your balance. But right now, people have developed applications over it, like Block Explorer or whatever Explorer you see, or your wallets, where you can see your money. But this money is bought from all the transactions you have done and collected. So this doesn't work like a conventional way of a bank. So if I move towards how the things go inside the blockchain and the Bitcoin, which works on the blockchain. So first I would like to introduce you to the hash functions. So does anyone have an idea or a brief of what a hash function is and what property does it give us? Like anyone could explain?
Is it a certain function that will take a hash and decode it into something legible?
Yeah, it's like it takes an input, which is X can be anything like number, text, paragraphs, anything. H is a hash function which can be like any of these, like SHA-1, SHA-2, these are like broken and old, they were the starting points. Bitcoin uses write MD160, and once you put in your value here and you use any of the hash function, you get an output Y, which is deterministic. What it means, like if you put 10 here 10 times, and use suppose SHA-2 10 times, you're gonna get Y as same. So it is deterministic function, the value won't change. Next, what is used in blockchain is called digital signatures. So can anyone like have an idea of what a digital signature is, like, or how does it behave in the internet market, or you call a digital market? So it's like when you send your emails nowadays, you have a column of putting a digital sign. So what does it mean? Like certain keys are generated, which are called like private key and public key. The private key is your signing key with which you sign the whole message, and it proves like it came from an authentic source. Like if you are sending an email, suppose inside your organization, it strongly holds that okay, this is the person and he's valid because his signature is attached, and that can be verified through a public key which you distribute. So you have a key generation algorithm. There are many key generation algorithms which can be used for digital signatures. It doesn't really like matter here. So you have a secret key which you don't distribute. You get it for your personal use and you save it somewhere secret. You generate a public key. So this public key is used for having the, once you sign and anyone wants to verify a signature, they use this public key, and with that they can verify that okay, this entity is correct and authentic and no one is forging his email to send, or wherever you want to use it. Right now it has vast applications. So you use a signature with the message. This message can be anything, email or your transactions, which I'll show you. And you sign it with your secret key, and R is the randomness. So any clue why this R came up all of a sudden in the signature, like any guess? This is just to provide randomness. Like if your message is same, you're sending same messages, and you sign your signing keys, obviously one signing key which remains the same. So R generates it randomness. So when a third party comes in and want to intrude, they won't be able to make out that you're sending the same message again and again, and it will always generate a different signature, but these two parameters remain the same. So to verify, you just send your message with the signature and the public key, and with this, the help of public key, it gets verified by the receiving end, okay, this is the right source, and you can trust it. So how does it work in this ledger-based system of Bitcoin? So first, you might have a question like, if no central authority is here, Bob can easily force this ledger saying, Alice has sent me 5 or maybe 100 Bitcoins, and who takes control of that? Who knows if Alice has sent it or not? So the answer to it is the digital signature. What happens is, like, each entity gets its key, that is like, this is the public key and behind it is the signing key. So the entity like Alice is binded with KA and Bob with KB. So whenever Alice does a transaction, she has to sign the transaction with the key. So when the other party receives it, it can verify, okay, that Alice has sent, it is this public key, I can verify the signature and the transaction can go on. Bob cannot force Alice's signature because he doesn't have her private key. So there's no point of forging. Instead, like, Alice loses her keys and then she revokes it, and then there's another process that goes on. So instead of sending directly 5 Bitcoins, Alice will sign this message and then Bob will verify it using the public key infrastructure, where you have all the public keys of the entities and you can verify the signature based on this. Also, it serves as a purpose of identity. Like in the blockchain ledger, once we'll proceed ahead and I'll show you the all the transactions live, you'll see that there is no name, like no Alice, no Bob, nothing. It will just be based on the keys, and no one would be like, you won't see the names. So any like thought about why the names are gone? Because in the banks you see like Alice or Bob is like, you see in the transaction details to whom you are sending, but here you won't see it. But what's the purpose of it? Why was it done? The main purpose is like lies here in pseudo anonymity. Like the concept was based on like it has to be more free. Like you see the ransomware attacks or the things happening where people ask money in Bitcoin. Why? Because you can't trace this key. They have like, a person can have like 15 public keys and 15, 16 or maybe 100 wallets, and then they can ask money 100 times in different wallets and never use, like transfer it somewhere and never use that wallet. So you won't be able to know whose key is this. If I give you a KB of like 126 bit or 256 bits, you don't know to whom does it belong. So this serves as a purpose of hiding your identity on the blockchain. Another structure which is most importantly used to make the blocks is called the Merkle trees. So in the Merkle trees, what happens is like you have your data coming in, like suppose in the Bitcoin, if I take an example of Bitcoin, you have 100 transactions happening in suppose 5 minutes. So all of these are transactions saying that this amount was sent to this or X amount was sent to Y. All of this gets hashed and hashed to a top level where you cannot no longer hash it. So the purpose of doing this is like if you have 10 transactions and you keep 10 different hashes, you're going to store a lot, first of all, and the size of the data will increase. Think about, like, I'm saying 100, but like in Bitcoin space, like it happened like 2,000 to 3,000 transactions in 10 minutes, and it's going on since like so long. So how much data they have to store? So using this hash mechanism which we discussed, all this data get compressed to one node, and you can also track back using, like, if you have L1, so like if you want to track this transaction, you just need this and these helper nodes. These helper nodes will be provided to you, and you can track back this transaction that, okay, this transaction is in this tree and this is called the commitment to N12. So this serves the purpose of picking up the transactions very fast because it's a tree, so it takes like log n time to pull in the values. And also it's like you can verify it very easily. If you you use like SHA-256, so you combine all this data in like 256 bits. So you just compressed everything, and then once you want to see this commitment to M12, you just need these helper nodes and your own original value. You go up and you can verify easily. The other purpose which it solves is like you cannot change this value. What blockchain is famous for is like immutability. Like you cannot change this value once you have put it in the blockchain. Why? Because if you suppose change this, the whole tree becomes different. Like this value would change, and if you have more blocks in ahead of it, which I'll show you, then if you try to change it, it will cause error in the whole chain, and they will say no. The people in the node network will say no, this transaction is not valid. So that's also a reason, like when people ask for ransomware and then they cannot revert the money back towards other people because it gets in the blockchain, and it's the blockchain protocol which will say no, you cannot do it because it's based on these values. So this is like, if you, that was the single structure of a transaction. If you say in time t, or I've taken time 4, so these transaction happens, and then you combine with it. This is called the Merkle root, which is the commitment. You bind it with another value, which is a random value, which is coming up next, which is the most important. And just consider it as a random value for now. And then you hash it again to get a block header. This block header will be hashed at time t2 with this Merkle node to get a block header again. So if you see, it's you are forming a chain of transactions over time n, and if you want to refer to this and you have that t4 Merkle block header, you can go all the way back to the Merkle path and trace this back. So this thing becomes easy and the storage space goes very less. So this was the background on the basis, like what works behind the blockchain or the Bitcoin transaction from where it started. So talking about the random value, I said that here we have a random value which is hashed again with the Merkle root to get the block header. So what is this random value? So the main question now comes in, if the transaction is happening, okay, I'm sending 10 bitcoins to my friend, I don't have 10 bitcoins. Who validates it? I put in my signature, I say, okay, this is my transaction, and my identity is validated, but how is this validated that I have 10 bitcoins? How does all the parties in the node, like network, reach a consensus like, okay, this transaction is true, valid, and you can go ahead with it? Also, if I am for, like, suppose right now I send money to my friend and another person sends it to someone else, how to bind it in a block? Which transaction to include in a block and which not? If you include everything all together, like it would be a mess, like a person pushing a block right now and within 5 seconds another block gets pushed. How will the nodes patch up, like cope up with the speed? If a node is like somewhere else, not in Montreal, and like somewhere else in Canada, and is operating on the blockchain network, it will take time for them to see this transaction. If you push it too fast, it's gonna mess up the ledger system. So mining is what gets the proof of work. The term for validating all these questions is called proof of work and consensus. So what happens is, there are certain special nodes in the network, those are called as miners, who are mining this process of generating the proof of work. So these nodes are also like a normal nodes in the blockchain network, but with the specialized properties of having the mining. And why they do mining? Just for like, it's like you earn money, it's like monetary incentive, plus they have like what you call the hardware to support the mining speed and process, which has grown up very fast right now. Because when this process started, you could mine on your personal computer, but if you do it right now, you need to buy a new one. So they have special process, architecture and special what you call like ASICs and GPUs, which they are using to mine the transactions and keep up with the pace. You can think of this random number is like an answer to a puzzle. If you like play a game of puzzles, you have to find pieces which fit in the proper what you call the bracket to make the picture complete. So this random number can be said as like it completes the picture. So all miners will compete to solve this puzzle. So once this puzzle, whoever solves it first, puts it in the block, the other miners who were fighting for finding it the first, then starts to verify, okay, is this number right, or that miner is cheating just because he wants to earn the money. So all miners will verify, okay, this number is right, he was right, and then the reward goes to that miner and the block gets coined. So you see it as a puzzle with M. M is any data. For us, M will be the block header, which is C here. Right. This combined with the previous block, once the chain is going on, so the previous block with this commitment and the random number forms the M. And this puzzle is a moderately hard function which can be tweaked based on the performance of the network. If the network like realizes like the people are having a lot of GPUs and they are solving it like within 5 or 4 minutes, the puzzle's difficulty will increase and it will slow down the speed of adding the block in the chain. And if it's like going very hard and it's taking like 15 minutes or like more than 10 minutes, then the puzzle will like go down in the difficulty. So the buffer time which was decided was like 10 minutes to add a block in the chain, and based on these 10 minutes, this function gets tweaked. The solution which is like then found by the first miner gets verified in the system, and then whosoever like finds it gets the block reward plus the block gets added in the chain saying all the transactions are validated, here is a reward, and it goes ahead. So this puzzle is nothing but a hash function which we saw it before. M was as discussed the nodes other than R. So why is the target value which has to be smaller than the given puzzle value? So to explain this logically, suppose the puzzle comes in like find a value which is less than 2 raised to the power 256 bits or 2 raised to the power 246 bits. This is decided by the network, like on the hardness or easiness, how hard or how easy the puzzle should be. So this hardness is decided, and say suppose the hardness now is 2 raised to the power 246. You have to find a value 2 raised to the power less than 2 raised to the power 246. All the miners will start competing, hitting the value, putting it here and checking if it comes out to be less than y. If someone is able to find it like say 5 minutes, he will publish it, okay, I found the value. Other miners will start putting this R with the block and then check, okay, this value is fine, and then they will go ahead saying, okay, this block is accepted in the network, and then the chain goes on. So it's like same, the group of nodes will compete. So it's based on luck and hardware. Like even if one miner has a very high GPU capacity and ASICs and he's like the top miner, if there is no luck, he won't be able to find, and some other person who has like very low, say comparatively low power is able to find. So it's also based on luck, like it's a random number generation. So if you hit that random number fast, you get the reward. So other nodes will verify, and if it's correct, it gets added to the chain. So what I was talking about, like the chains, like if you start pushing the blocks all together, then it's going to mess up the system. So this gives the time for the transactions to appear. Like if it's the 10-minute buffer time, no block will come before 10 minutes. So all the nodes will have time to refresh their ledger, and then once this new block gets created, then again it's a pause for 10 minutes, and all the nodes will be able to see, okay, the new blocks have been added or the transactions have been added, let's add it on a ledger and go ahead. So this solves multiple purposes and it's like really important. Nowadays what's like the proposal is going is like this is proof of work based, so you need higher GPUs, processing powers and electricity. So many other alt chains like Ethereum, they are proposing proof of consensus based mechanism where whosoever has larger majority of like stocks, if you think in terms of stocks, will be able to verify it faster than the other, so it puts down the load on buying new GPUs and electricity, but it's like having its own sorts of problems, so it's still not in the line of putting it like proof of changing this. So this is like used everywhere in the blockchain. So any questions regarding any data structure or the background before moving on?
So does every blockchain, and not only Bitcoin, every blockchain created, does it have mining nodes as well?
Yes.
So it's just a function, a way that the
Yes.
blockchain could give time for all the transactions
Yes.
to be accumulated?
Yes. The fundamental is like miners, like nowadays, like before when it was started, like there were different miners in different, for like suppose Ethereum, I'll only mine Ethereum. Then they were like, I'll only mine Bitcoin. But now, since it's like getting combined, you call it like as mining farms. If you search on internet for blockchain or Bitcoin mining farms, those people, like they have like farms set up like data centers. And then what they do is like, they distribute their like power to like, okay, this much power to Ethereum, this much power to Bitcoin. So it's like one system like mining, and if like another chain comes up, okay, we are not going with proof of this thing, we'll use like proof of consensus or any other thing. So then they set up their own, or they use the own, like if, it also depends on the miner. If the miner isn't interested, like he doesn't see any profit or benefit in like mining those coins, then no, they won't do it, so no one would do it.
But let's say you have a blockchain that has nothing to do with currency. Let's say you're using a blockchain as just a regular ledger system to track a certain value.
Okay.
It will still have miners.
To validate any transaction, like everything is called as a transaction.
Okay.
Even if you are doing certain state changes in your functions, it is also called as a transaction, and to say go ahead with this transaction, you need mining.
Okay.
Yeah. Any other questions? Okay, so this is like conceptual how the transaction looks. So there is a transaction ID. You have the input like 3.5 Bitcoin, 2.5 Bitcoin. This is the keys. Like this key belongs to one person. Like he can have many keys, as I told. Like you don't know how many keys, or maybe it is his partner, or maybe some friend who is combining this value. They are sending it to B1 and A3. They are sending 5 and 0.99. What does this imply? I'll just tell. And they are signing it with their keys, like it's A1 and A2 get signed. So the validation is done. Now talking about the values, where does this 3.5 come? This 3.5 comes from the transaction ID 5292. What happens in this like Bitcoin, or what you call it, blockchain currency system, the output of the previous transaction acts as the input of the next transaction. So this acts as an input to this transaction, which was the output of some other transaction. So it's like based on a chain. As I told you, don't have like a bank ledger system where you have money all in one place. So this is like important to note that this is output of some other transaction now acting as an input. Similarly there, like 3928 is the output which is acting as an input. So A1 and A2 wanted to send 5 Bitcoin to B1. What they had was 3.5 and 2.5. So it similar, if you compare it to a bank, you can directly subtract from your balance and send whatever is required. Here you cannot do it. You will send whatever you had, which combines to this value or more, and the rest come back to you as a change, which is A3. A3 also belongs to some person who's getting it to A3 and wired to maintain the anonymous, like he doesn't want anyone to know where he's sending money, so he's sending from one place, getting it from other place. And if you notice, it's 0.99, not 1, like 5 plus 1 is 6, this is whole 6, but you see it's 5.99. So where does the rest of a small amount goes? And guess? It goes to the miner who mines the transaction. It's the mining fees. So it's his decision to give that much amount to the miner. So it goes to the mining fees. So this is like what a blockchain is working as in a diagram. So B10 happened 10 minutes ago. Now it's time for B11. So B11 will combine B10. This is the hash of all the transaction, which is the root. The game is for finding n. Whosoever finds it makes B11 and it gets accepted. This B11 goes again in block 12, and all these transactions again like form the same process, and this is how the blockchain is derived, like blocks with a chain. So this is called blockchain. Yeah.
What happened to the first transaction?
With the first transaction, like when it was launched,
Because there's no,
yeah, it was some random value generated by the inventor. He put that random value, he said it's fine, and then the chain started. So it was like you push the coins to start the engine, and then the engine goes on.
It has to be a first validation.
They validate it on their
There's
own.
no
Yeah.
debt, right? Has no money.
Yeah.
He has to say, hey,
Yeah, that's why, because they, like, when he invented the system and put it in action, there were like 4 or 5 people. When I'll show you the block explorer, then you can see that they transferred it within themselves, and he only made the transaction. He only mined his own transaction, because that time you could mine, no one knew blockchain is there. So he mined it on his personal computer, said the transaction is valid, and go ahead. And then this transaction was valid. It was like he submitted he sent money to his friend to mint the coins, and then the random value was found out on his PC. He only validated with a group of friends, and then the chain moved ahead. Yeah.
Does this mean that there is a fixed amount of bitcoins?
Sorry?
Does this mean that there is a fixed amount of bitcoins?
Yeah, there is a fixed amount of bitcoins that's calculated based on the math. So it's like said like after like 5, 6, or maybe 10 years. It's growing. I don't have the right values right now, but yeah, it's like fixed amount. After that, there will be no more bitcoins that will be coming in the market. Once it's like whole came in, but it won't happen too fast, because the value of monetary value of 1 bitcoin is so high that people send it in chunks, like to do the transaction. So it's gonna take a while, but yes, it's like after a while, no more minting of bitcoins will be done.
So you said this system is mostly to have a step, so all the transactions could be processed within that time. And you said that there's a maximum amount of time where if the puzzle hasn't been solved in, let's say, 10 minutes, then it'll step down the difficulties.
The difficulty is decided before solving.
Okay.
So it's like the 10 minutes is the buffer. So if the network notice, okay, the past 2-3 transactions are taking 12 to 15 minutes, they'll lower down the next, what you call the puzzle strength.
So the benefit of having a system like this would be to have a dynamically adjustable time instead of having a set static, okay, 10 minutes per refresh time.
But it's like what the miners have, like the blockchain basics have decided. It's not like you don't play a role in this. Instead, if you are a miner and you are making your own chain with your own, like, Ethereum has like 5 minutes, and 1 or more examples which I'll be showing you, they have 2 to 3 minutes. So they have reduced based on their own. They say, okay, we want to do it in 2 minutes. So but Bitcoin works on 10 minutes. So it's the person who's making this chain, or the, what you call the alt chains, it depends on them. So this is the one of the used blockchain.com explorer, where you this was built up after the system got up. It didn't existed before. So here you can see these transactions happening. So this is the current height of the chain that is going on. It's aged 5 minutes, so the puzzle was very easy. You see 5 minutes, and now it's so it's gonna get fine. Transaction 1, there is only one transaction in this. Who is the miner? You get the name and you get the size, how big is the block size. So if you go in, you see the number of transactions. So 2, 3, 5, 4, it's the number of transactions in this whole block. So every block has an average of 2,000 transactions. This is the total output, total bitcoins sent, and this is the total volume, and this is the important fees. If you see the fees, this is the total fees collected by the miner who mined this block. And whatever the name was, he got this because he was able to match that puzzle. The time it was done and when it was received, you see the difficulty is also in bits. So every block has its own difficulty. So you will be able to see here the difficulty value. Yes, and this is the block reward. So instead of along with getting the transaction fees, there are newly minted bitcoins coming up in the market. So earlier the speed was very high. Nowadays it's 12.5 bitcoins per block. So this money plus this transaction fees goes to the miner who did the mining. So this way new bitcoins come in the market and the miner gets their incentives. And if you look here in this block, you will see the hash. This hash is the transaction hash, that 2,354 transactions, that's the hash. So all these transactions lie in there. So it's you save the space. Previous block was the block before this, 29. So that's his hash. The next block, because I opened a block before, so next hash of the block, so that's generated. And this is the Merkle root, the root which is generated before getting the random value. This is the root for all these transactions, and when combined, we get the hash with the R and the previous block. So that's the final value which we use. So if you go on this chain, you can see everything. You can host your you have Ethereum with Bitcoin Cash. You see the price. You see the hash rate. So this decides the difficulty. If it's you can see how if it was varying for a day or months or weeks. And this is average fees. If you want to provide some fees to see what the average fees is going on for the transaction, so that you don't spend more for the fees, and your block also gets accepted, because it depends. If you don't give any fees, why would the miner mine your transaction and put it in the block? So you need to give some incentive to them. You see the transaction, these transactions are coming up. You see the speed, it's going on. So these transactions after 10 minutes will get bounded in the block. So these transactions are happening but still not in the block. So if I catch and open any one, so you will see the input. This person, you don't know who is this, sends the money to here and here. So if you see where this person got the money, if you click here, you can see this whole transaction ledger from where did he receive it and where he is spending. So you can kind of track the address, but you don't know to whom it belongs, and then if you know your friend's address is this, you can see how much money he has. And then this is the fees for the transaction. So this transaction itself only carries this, and it depends on the bytes, fees per byte. If you're sending more data, then maybe the fees goes up. So if you host a wallet on this, I won't go in because it needs login. I don't have a wallet right now. So if you go on a wallet, so if you do a transaction, it's now built up in such a way that it will help you set the transaction fees seeing all this data summary, it will tell you, okay, your transaction is this much, please put at least this much transaction fees to get accepted in the block. So the wallet has grown a lot, so you can like easily see how much you have to pay. Same thing which I explained, like the addresses, input address, that's the new address, the amount, same, it's the same. I just put a snapshot and then like just to have a reference. And this is the block which I offered like today. The latest, this one is pretty old, like 2-3 months back. So let's talk about applications of blockchain. So Bitcoin was like, the Bitcoin blockchain is like, was the base from where it all started, but it had a limitation, like you cannot do more in that space. Like it doesn't allow you freedom to code or put in your own data other than just sending money. It has certain options, but it's like very limited where you can like put the hash and all. So people came out with other chains. The one most popular is like Ethereum, which also has its own currency, Ether, but allows you to do the code. Like if you want to build decentralized applications in today's world, like if you don't want to host your application on a centralized server, then Ethereum is a good bet because it gives you a lot of freedom and it's like polished a lot over the years, so it's like quite easy to make your application. So it's like just similar, it works on the similar grounds of the blockchain. It has certain differences in the data structure, like the Merkle tree. It uses more advanced type of the Merkle tree. So it's like having more efficiency, and then it goes very fast. It's like 5 to 7 minutes for the block instead of the 10 minutes. So they have changed the logic. It's like the data structure uses different. It has the bytecode. So the bytecode is like the smallest form of like once you code the smart contract, once you compile it, you will get the bytecode because one of the programming language is Solidity, which I'll show you a bit. It's Java based, so Java has a bytecode once you compile it, so it works on the same basis. So you call them DApps or decentralized applications. One of the applications I will be showing you, which I built as a prototype for my project. So based on that, I will discuss how this works. But I'll just give you the overview. So this is, suppose your code. You have some functions, you put some states, and you have the constructors. So once you do a transaction, the first transaction on the blockchain is to put this code on the blockchain. So this code is like termed as a smart contract, which is called because it's named that way. And the first transaction creates the DApp. So it's like putting your smart contract on the blockchain, and that also has its own address. Like I'll show you, you will be clear about it. Every smart contract has an address of itself. And then when you run a function, the function causes a state change. A state change means a transaction, and that means you have to like put some fees and then you change it. Like if you are doing some addition like 3 plus 4 and you have a function to calculate it, you input the data, you don't change the state. But if you do 3 plus 4 and you press the button, then the state change happens because you're doing an addition. So that transaction also gets noted on the ledger and you can like track that. So the key features are like the DApps need to be in code. It's not like it will work based on, okay, you set an alarm for 6:30 a.m. in the morning, it will go up once it sees the time. No, you have to put the input to make it work. It won't work on itself. Like if you program it, no, it doesn't work that way. Once deployed on the blockchain, there is no way to change the code or the application. So this is like really critical. If your code has a bug where anyone can attack or like drain your money, if you're putting money along like the Ether along with it, so you have to be very careful. There are certain test networks before putting this on directly on the chain. So you have the test network where you test your code for everything, and you see. And if once you find like, okay, you didn't found it on the testing, and then you found it once it's deployed, you have to like revoke it back, and like it will still remain there, but it won't be functional. It's like that. So this has to be like really careful. It involves the transaction cost. Here they have named it as gas. So what is gas? How it works? We will see it. So every operation that you call, like what the addition function has said, if you have a function with just 3 plus 4, it will involve a cost which will be the transaction cost. Why we use it? We use it to prevent the denial of service attacks and to generate revenue. If someone is very malicious and wants to bring down the chain, what he can do, put an infinite loop, deploy a smart contract and invoke it. It will keep on running, and if your normal applications, you don't put a transaction fees. So what happens? Your code keeps on running. Here, if it keeps running, the miners will get confused, like what's happening. They're going to like check it, and the system will come down. So to prevent this, we have the notion of gas. Like every state change requires certain money. So if you're putting an infinite loop, you have to spend a lot of money, and like this solves the purpose. They have Ether, which is the Ethereum currency, like Bitcoin, and it keeps fluctuating like the stock price. If you see every day, you see it goes up and then it crashes and it goes down. So to remain constant for the functions cost, we have the notion of gas. Like you pay in Ether, but it's calculated in gas. And how it's calculated, we'll see. It's like pay transaction cost in gas, and the Ether value corresponding to it get debited. So the two components is the gas limit and the gas price. So think of it as if you go on a gas station and you want to fill up your gas. So if you want to put, suppose 5 liters, so it's your gas limit. And gas price is the price of today or yesterday, whatever it was. So when you multiply it, it's the total transaction cost you pay. So it's in the similar way, when you do a state change or you deploy a smart contract, you have to put a gas limit. The gas limit won't make it like your transaction will come in first or not, because it's just the limit. If your function requires, suppose 2000 gas limit, like 2000 gas, and you put in 4000 as a limit just to be on the safe side, you'll get the 2000 back. Gas price is the price per unit. So if it's like 1 and you put, if it uses 2000, so you're paying 2000 gas. So that 2000 gas, what it corresponds in Ether, you will be paying that Ether. So to make your transaction go fast, you have to increase the gas price and not the gas limit, but you don't increase it that much that for a small function you pay a lot of money. So for an example, this was the architecture of my own prototype. So what my problem, like what I thought was for a supply chain based on the pharmaceutical side. So now if you go and buy a medicine from like any pharma store, you don't know from where it originated, like who was, you know the manufacturer, but can you say, okay, it wasn't pampered during its coming in from the manufacturer to the hospital, or once it reached you, or once it reached the head distributor. So the customer doesn't have any visibility, instead of trusting the pharmacist that okay, the medicine is right. And in many places in the world, we see that these medicines are getting fake and counterfeit drugs are being sold, which are like causing harm to people's life. Like people are falling ill more and even leads to death. So to prevent this, what I thought is like the customer should have the right to see from the manufacturer till from where he buys the medicine, like he knows the transactions where it's happening. And I chose blockchain because it's like I don't want any centralized system to govern it. Because if you have a centralized system and then if they are doing certain things which are like not right, then again the system fails. So I'll show you my contract as it has the code, so I'll explain you from there. My contract is mined at the Ropsten test network, which is the Ethereum test network, one of the Ethereum test network, and this is my address, smart contract address. So this is my contract, which I did it like here. So if you go here in code, it's like a basic. It's like not that hard to understand. Like instead of class, we make a contract manufacturer, which was like the name I gave. The solidity is like I was using the 4.2 compiler, but like now it has gone much above, and like all sorts of compiler are present. If you don't want much functionality, you can degrade, or if you want more functionality, you can upgrade. Then I created certain structures in which I have this data to put in. And this is like similar to hash maps, like mapping data structures, which I use to map. I won't go in deep because it's gonna take too much time, but I'll explain the overview. So this was the functions, which was like first creating the product. Once the manufacturer creates the product, he will put it on the chain. Okay, I created this much amount of medicines, and this is the transaction, when it was done, who am I, what is my public key, all that goes in. Next, when he sends it to, suppose, the head distributor, there is a shipper. So shipper will do the transaction. Okay, I collect it from the manufacturer, it is going to the head distributor, I am the shipper, this is my key. So he owns the data, the medicine and the data. Similarly, from the head distributor, now it goes to the regional, like the head distributor is far away and he has certain small distributions. It will again go from the shipper, so the shipper will again say, okay, now the source of data or the medicine, what say is the head distributor going to this regional distributor, and this is the amount of medicines going in. From the regional, it goes to hospitals and pharmacies, and they again do the transaction on the chain. So, and similarly, once the customer receives it, the customer is able to track back with a function which I have created. I'll show you. Here it's like different contracts. You can see creation code in like very easy, and you can see like op code. It does in op code, so you have all the op codes. It's like having quite visibility here. From here you can also like you can write the contract. So yeah. So these are the events. So if you see method sold to customer, this was my last call. So this was the function which was called sell product. It was the sell event, the product ID, who sold it. This is either the hospital or the pharmacist, and this is the seller name. Like I put in the address as the name for more visibility. Like here you can tweak, but in Bitcoin you can't put in the name because it's like static. So if you go on all these transactions histories, you can see, or maybe events would be much better because I'm using events here. So see received from. So this was product was transferred. It was in the event of ship event with the product ID. What was the product ID? Going from regional to customer or manufacturer to head distributor. So it was like a complete data mapping, and the customer won't see this because this is the. It was like a script which was going and using the API for the test network, pulling up the transactions. If you see the source was Ranbaxy. It's the public address. Even if someone puts in Ranbaxy, this address cannot be generated because it's generated from the private key and only Ranbaxy holds it. And my system, what I made it was that there will be an authority who will be distributing these public addresses and can be revoked if you see there is like they are doing not the task which they are assigned. So you can see the transaction time. This time is given by the blockchain. So it's like hard coded. You won't be able to change that time. The time comes in on its own. So it's like, okay, you see the transparency if it's not like, it was the sensitive medicines which require like temperature modulations and all, and if it's like getting delayed and then also sold, this can be seen, okay, it was shipped 2 days back and what I needed it it's getting delayed for a day and you can see it, then where was it? So then it goes from the source and destination, and last it reaches to the seller. So it was sold by the seller. The public, like the person who bought, won't have his own address. Like he won't put it for like being a security reason, because I don't want to see who bought this. So that person can see, okay, this is not resold and it was sold by retailer 1, as I gave the name. Now again, if the retailer wants to sell this thing and the other customer will pick this address, track and see, okay, this was already sold. Okay, so this drug or this medicine is like forged, or there is some problem in it, so we won't buy it. So this was the whole prototype which I built using Ethereum. So the coding is like, it's not that hard. It takes some time to like learn. It doesn't have a lot of like what you call data structure or long codes to go through. It's like simple, if this then this, it goes in this sequence, so it's very easy to write down. This is what I showed you on the rope stand. So I have a snap here, and this is my contract address in hexadecimal. So this was it. For the future upcomings, like the current things which I am like researching on is like this kind of transactions for supply chain goes fine if you have small data. Suppose of what I thought was having the health data of and the diet pattern of everyone on the chain to have a medical unified record, so that it can be viewed anywhere. Like if you are not in Canada and if you are traveling somewhere and you fall sick and you're not able to explain to the doctor, how will he come to know if you are on any medications or if you have certain health complications? So for that, if you use a decentralized system, no one needs to put up like servers or special things to hold this thing. This just need an address, and they need to connect to this chain to have the health data and the diet pattern. Like health data was worked up upon by many people, but the diet on blockchain are like very few people have thought about it, because it's like intensive and people have to really participate in that. So the biggest hurdle in this is, okay, you will use the blockchain, but where will you store the data? If you start like storing on Ethereum also, it also has a limit. It will slow down, your transaction cost will go up. If you like storing 2 gigabytes of data on the chain, then it's not good. So this is the limitation of even the smart contracts. So nowadays, if you take like, first you think database or blockchain. Like if you have a fork and you have to decide database or blockchain, there is like nothing a database cannot do which a blockchain is doing, except of this decentralization and anonymity. If you need more storage and more access speed and you don't care about decentralization, then database is your choice, because it's like well versed and it's coming up since ages, and blockchain is like still under work and going changes. It's like more reliable. Sometimes the blockchain network goes down for maintenance, and if you are losing that data, then you need to wait or pause your work. The major disadvantage of blockchain, what I discussed, was the property of being decentralized. Like if you want the data to be decentralized, like in my case, what I thought, no one should be able to change the medicine data. It should be, if it's done, it's done. So, and immutable. So blockchain is your preference, and if you don't want the third party to set up servers, they just need the address, the internet, and they can go on. So it just makes the data to be shared across the nodes in the network. So it makes it easy. Like if you're nowadays you use cloud storage system, we can access our data anywhere. So similar, based on that, we can use the blockchain data applications if you don't want to boil enough this. So what I discussed, right, like storing data is expensive and it's slow with flaws if you want to store large data like health records over the age and like diet patterns. So there are researches and like still developments going on to how to link the blockchain with the off-storage data, or creating decentralized data storage which work on blockchain but work as a separate entity to work with your application. So there are two decentralized processes running which are independent of itself, but they solve the purpose. One solves the purpose of storing the data, and one gives you all the decentralization and immutability for your application. So few of the chain which I am working, I'm doing the research, are like IPFS based storage, light streams, blockchain based clouds, data lakes. So what does this do? Like IPFS is like, if you know BitTorrent, how it works on the similar ground, like it's interplanetary file storage system, where the data gets divided into the nodes that have set up this system. Like it runs as a decentralized system with, like, suppose 10 nodes are, okay, we'll run this IPFS and we'll host people's data. So what they do is they distribute the data, and each data gets distributed in the nodes with no duplicacy. If there is duplicacy, it gets removed, and the data as a whole gets into a hash. So you get a hash of the data which you can store on the blockchain. So you get the decentralization notion of tracking the transactions. Okay, my data went through this, but my data lies in IPFS based storage, so you're not burdening up the blockchain with storing large amount of data. Similarly with Lightstream has to, is going to be launched in 3 to 4 days to public. So what they did is, like, they combined the IPFS storage with access control policies. Like if your application is more complex, if you want only the admin to change, suppose, the passwords, and you don't want the users to do it, so you have the access control policies. Lightstream has combined this IPFS with the access control policy and this access control policies are stored on the smart contract, and the data is on the IPFS. So it's like you're getting best of both. Blockchain-based clouds, like few of the technologies are coming up which are making blockchain-based clouds, like Google Cloud and OneDrive. They're having blockchain-based solutions where there are decentralized nodes which are having the power and they have the computation systems, but they are not using it. It's free, so they start hosting these storage systems where the data first gets distributed into small chunks and then goes randomly into the network. Even only the owner knows which nodes it is, no one else knows it, and you get the hash, like a tag to the data. And this technology, once it gets into full force, is going to be much cheaper than what we are paying right now for the Google Cloud or Apple Cloud, because people are hosting this service and they can go a lot, like you can have a lot of nodes, and so the price goes down. Data lakes also, like, stores any data. If you don't have to, like, format it, you can put in graphs, pictures, anything, and like data lakes uses its own AI-based systems, and and it changes the data, segregates it, does analysis. So this is good for if you want to do the analysis of the data but have a tag to the blockchain. So these are the few technologies which are getting merged with the blockchain to provide more help. So just key considerations, you need to think before choosing a platform. If you want centralized storage versus decentralization, why you need it, you need to brainstorm a bit. You need to build a way to capture the crowd to use the application. This said, why? Because each transaction costs transaction fees on the blockchain system. So if you get in your application, it's very good, it works amazingly, but the user has to pay a certain amount. Many users won't, because if a non-technical person who doesn't know what blockchain is, instead of trading in bitcoins, he won't understand the importance. So you need to have some intensive incentive generation programs, like giving them money or giving them, like, okay, you use my application for 10 days, you'll receive certain amount, you can use it for transaction costs. And by this way, you can start building a base. You have to be ready to, like, face issues and hurdles as the technology is, like, still developing. There might be certain functions which you think, okay, you can do with blockchain, but once you start coding it, you'll see, okay, it doesn't exist. You have to build it from the scratch. The libraries are still not there or not efficient. So you have to see that. Never forget the gas cost, and always test the application. Like testing the application for any errors plus the gas cost. You can test it on what you call the Ropsten, one of the test networks, or you can go any test networks, and you have to check if this is increasing, this will increase, and the incentive thing will also fail, so the whole system then doesn't work well. Any questions?
Transaction.
Sorry?
How cost the transaction with the application?
How much does it cost? It depends on your function. Like if you are only, suppose you are sending 1 ether to your friend, it would be 0.1 into 10 raised power minus 6 ether. But if you are sending chunks of data, like let me see if I captured my transaction cost, I can show the variation. You see here, like all of them have a different value based on how big the function was. If it was only the retailer calling, the customer calling it only for validating, it was just 2 lines of code. For sending, it was 4 to 6 lines plus a function call plus a map, so the cost went up. So it depends on the code and the state change code, which is like line, how much it costs. So once you you can use various development tools, like there is like Remix IDE, which is like just you log into Remix on Google, you open it and the IDE is ready, you don't have to install anything. One is like Truffle network, where you install and then you have the command line base. So once you put it to run for test run, it shows you how much gas it will cost you, and based on that you can take a decision, okay, do I have to optimize or not. It also tells you, okay, your function is gonna cost you more, please optimize it. So these things are like built up with the use cases. Any other questions?
So I have another question. Taking blockchain as an example, this is not blockchain, Bitcoin. You said that there's a finite amount of Bitcoins available.
Yeah.
And then you have the miners that always take transaction fees for
Yes.
every block they mine.
Yes.
So is it not a system that tends towards the miners having all of the blockchain as time, all of the Bitcoin as time goes on?
No, like it depends. Like the miners are also, what would the, like if the miner collects suppose 100 Bitcoins,
Right.
he has to fill up his cost also, right? He has to spend it somewhere. So maybe he goes on the exchange and exchanges the Bitcoin for the US dollars or whatever currency he needs. Or maybe he spends it like to someone doing transaction, like most of like coffee shops here are also taking what you say, the Bitcoin to get you coffee. So like maybe they have to use it, like what they will do with the currency piling up and not using it for their own good. Like their GPUs might also need repairs, and they need to put like electricity cost, and also they convert it. You can convert your Bitcoins on stock market and get the real money if you want.
Okay, so it assumes that
Yeah.
there's an ecosystem where they are putting the Bitcoins back into the system.
Yes.
Okay.
Like if there is someone who wants to buy from you 100 Bitcoins and give you the US dollars, so
Right.
it exchanges, and then that person might exchange it at a later time, like when the price goes up, or if he sees okay it's going down, he sells it. So this way.
Are there any measures put in place with the Bitcoin system to ensure that nobody hoards Bitcoins in a sense?
It's
or not really?
they usually, like if they hold it, it's like for them, like it's of no use. Like if you have a $100,000 and you keep it forever, then you won't use it for anything else. So that's the similar notion based on the currency, like they spend it. If you go on the Block Explorer and you see who mined it, you have the address. You can click on their address. You'll see where all they spend. They do spend it in like large amounts. Yeah. Any other question? So if you have any questions or discussion, you can like connect on LinkedIn. It's the barcode. You feel like you can scan it, and I'll be happy to help if you need any help in the future. Thank you.
All right, good. So many thanks to all of you be today with us for this great presentation. So the buffet is still here, so I guess maybe you need to refresh your brain and take some good drinks to kind of learn all the things Abhinav has presented today. Merci beaucoup à vous tous. Il y a encore un buffet pour ceux qui veulent rester un petit peu plus longtemps avec nous et peut-être qu'il y aura d'autres questions qui viendront. Merci à vous d'être venus et à très bientôt. Merci.